Welcome everyone.
Hello, sir.
Okay, so let's continue today's session. Okay, today we are going to cover the. I just see that first. What we have to cover today. We have the ridge, lasso, and elastic net regression. We have to cover. Then we cover about the segmentation and clustering. So I just see where it is.
Excuse me, sir.
Yes.
Sir, I did not receive any study material after the first two classes.
Oh, see that the same link is there.
Okay. Okay. Thank you.
You have to go to the same link. You will get the day-wise material is there.
Okay, sir. Thank you.
Okay. If you get any problem, you could WhatsApp me later on. Okay.
Okay, sir. Okay, sir.
Just a moment. Mhm. That BPT I have written for that. I am searching that. Regularization I have written something. Okay. Okay, so I think the my file is somewhere in this place, so I will search it out and tomorrow we cover that part. But today we cover our cluster analysis and segmentation. Okay, we cover it tomorrow. So tomorrow we are covering the segmentation cluster analysis, and sorry, today we are covering this, and tomorrow we will cover that ridge lasso and the elastic net. Okay, that PPT is not there somewhere; it's misplaced in some other folder. So I will get it, and then we cover it tomorrow. So today we cover the segmentation and clustering, which is our last topic. Okay. So I share my screen with you. So I think you are all getting my screen. Okay. And let's continue the session. Cluster analysis and segmentation. Why we do it? Okay. So what is this for? I explain you first why clustering. In data analytics, we often have very large data, many observations rows in a flat file, and which are however similar to each other. Hence, we may want to organize them in a few clusters with similar observation within each cluster. So clustering techniques are used to group data observations. Observation wise, we are grouping it. In the feature engineering, you have seen that we were making the factor analysis. It is the column wise. Factor analysis is the column wise. We are dimension reduction. Or clustering techniques just for the observations. Observation wise we make some groups, and clustering techniques are used to group data observation in a few segments so that data within any segment are similar while other data across segments are different. Got it? So defining what we mean when we say similar or different observation is a key part of cluster analysis, which often requires a lot of contextual knowledge and creativity beyond that statistical tools can provide. Okay, there is some your creativity is also required there. The clustering is the process of using machine learning and algorithm to identify how different types of data related and creating new segment based on the those relationships. Okay, clustering finds the relationship between data points so they can be segmented. Data points are the observations. Okay, they can be segmented. So there are various types of clustering. The clustering, we have the hierarchical clustering and the partitional clustering. So in the hierarchical clustering, the agglomerative, divisive, and the partitional K-means and the Fiji C-means clustering. So hierarchical clustering, also known as the hierarchical clustering analysis, is an algorithm that groups similar objects into groups called cluster. The endpoint is a set of cluster where each cluster is a distinct from each other cluster, and the objects within each cluster are broadly similar to each other. Okay. And agglomerative hierarchical clustering is the most common type of hierarchical clustering used to group objects in clustering based on the similarity. It is known as the agnes, the agglomerative nesting, and it is the bottom up approach. Each observation starts in nodes cluster, and pairs of cluster are merged as one moves up to hierarchy. How does it work? Make each data point a single point cluster from n cluster, and then we find out the distance of that, and that way we do that. So take the two closest data points that make them one cluster. Okay. Uh, and then take the two closest cluster and make them one cluster from n to cluster and repeat. So I will explain you here little bit. I give you an idea about it. Just a moment. How we approach it, how we perform. So I just explain here uh, with a small visualization. Suppose we have these data points. Okay, and so we find out the distance. This is the x1 and x2 and x3 and x4 and x5 and x6. So we find out the distance between them. Okay, so we find out the distance between these two, then distance between these, then for each point we measure the distance of each point. So we see the smallest distance is what. So we get this smallest distance here. So this would be our first cluster. Similarly, we are getting the distance with other points. Okay, so we are getting the distance with this point. Now this is now here, and we see the distance with this and this and this. We see the smallest distance here. So it is another cluster. Got it? This we have another cluster. Similarly, we get this cluster. Now we find out the distance between the cluster. There we have many techniques. We could find out the mean of this. Aggregate measure method is there. There is a minimum, we could say the single and the complete and this sort of methods we use. So I will explain you later on how we merge this cluster and then we make. So it starts with a single point. Does that make sense to everyone? The basic idea? Yes.
Yes, sir.
Okay. So this is the basic idea in the hierarchical clustering. Okay. This is the agglomerative hierarchical clustering. See, we start with a single point. Okay. And so I explained the agglomerative hierarchical clustering with a complete linkage, single linkage, average linkage, centroid linkage. We have the four techniques. I explain you one by one. There are several ways to measure the distance between cluster in order to decide the rules of clustering. And they are often called linkage methods. And the sum of common linkage methods are the complete linkage. The distance between two clusters is defined as the longest distance between 2 points in each cluster. So I will explain you that I have made some visualization of this complete linkage. You see, this is the complete linkage. So we are taking that this we have accumulated through the single points observations and then group, and then we are finding the which group should be merged. So we see the distance of the farthest point, this distance, and here the farthest point, this distance, and we see the minimum distance is where. Here also we finalize with the minimum distance. So this distance is less than this distance. Got it? So these two groups will merge together. Got it? In the complete linkage. Any doubt?
No.
Okay. In the single linkage, what happens? We see the nearest point of the groups. So here you see the nearest point and the nearest point. So here, this group, these are the same. You see, these are the same. Copy and paste I have just. And you see here is the minimum distance. So these two will merge together. So here you see here it is merging with this and here it is merging with this. It depends on the single linkage and the complete linkage. So you require your creativity and these all things which should we finalize. Got it?
Sir, it's mean like in complete linkage, we can create single linkage, incomplete linkage.
In complete linkage?
Like in complete linkage, we can create single linkage also. I mean, within the complete linkage.
No, anyone you could follow. Either you could use the single linkage or you could use the complete linkage. We have the 4 or 5 techniques. We could follow anyone.
Okay, sir.
So
Okay.
it means
Yes.
So it means like in complete, always farthest distance should be taken.
Yeah, farthest distance should be taken, and which is the lowest farthest distance. We have to consider those group together.
Okay.
Okay, the smallest farthest distance.
So smallest, how like farthest if it will be like.
This is the farthest point we are measuring.
Yeah.
Of the both group. Suppose it is we are getting here the distance. Hypothetically, I am telling you.
Okay.
Here we are getting the distance 78, and here we are getting the distance 65.
Okay.
Got it? So we will finalize the smallest one.
Okay. Okay.
So we will merge these two. We want merge these two.
Okay.
Got it?
Yeah.
Here also we are getting here 7 and here we are getting 12.
Okay.
So we merge the smallest one.
Okay.
Always we choose the smallest one. Keep it together.
Okay.
Either it is single linkage or the complete linkage. Got it?
Yeah. Thank you, sir.
Then we have some other methods I explain you. we have some other methods. It is a centroid linkage. Centroid linkage, we find out the centroid of this. Either it may be mean or the median or the mode, whatever you write. Okay. Got it? These points may be mean, median, and mode. It depends on the skewness or the symmetry of the data. Got it? And we see the distance. If we have some other group also, we see their distance. Wherever the smallest distance in the centroid, the same procedure. We merge those two groups. Got it? I have just prepared two. There may be third also. There may be third also. Okay. And we put here some points. And this is our, and we see this distance also. And this distance also. Got it?
So smallest distance will be taken in all the
smallest distance,
Okay.
always the smallest distance.
Okay.
Any of the technique, you have to use the smallest one. Okay. So this is the centroid linkage. The average linkage is my favorite one. Because here we see the distance between each and every point of the group. Getting it? The distance between this point distance we are getting with all points. Got it? Every point distance with each point. Got it? Love each point distance with every points. Got it? Of the other group. Is there any doubt now?
Sir, each point distance with every point, then it will take average.
Then it will take average. Got it?
Okay.
So we add all this, how many points, how many pairs are we have? Got it? How many these lines we have? It means the pairs. So we divide by those pairs. Okay, number of pairs. Got it? So that is the average linkage. And we have some other group also. We are measuring there also this way, each point, and there also we are measuring it. Wherever we get the lowest average linkage, we merge them. Got it? Any doubt now?
No, sir.
So these are the techniques for the hierarchical clustering. Okay. So we come back to our script. So complete linkage I explained you. Single linkage also I have described you. The distance between two clusters is defined as the shortest distance between 2 points each cluster. This linkage may be used to detect high values in your dataset, which may be outliers as they will merge at the end. Okay. And the average linkage I have explained you. The distance between two clusters defined as the average distance between each point in the one cluster to every point in the other cluster, as I written over there. The centroid linkage finds the centroid of the cluster 1 and the centroid of the cluster 2, and then calculates the distance between the two before merging. So the choice of linkage method entirely depends on you, and there is no hard and fast method that will always give you good results. Different linkage methods lead to different clusters. Okay. Got it? So there is nothing scientifically absolute scientific, we could say that. Agglomerative hierarchical clustering, if you see, so it is a dendrogram. If we make a figure of this, it is called the dendrogram. The point of doing all this is to demonstrate the way hierarchical clustering works. It maintains a memory of how we went through the process, and that memory is stored in dendrogram. So what is dendrogram? Dendrogram is a type of tree diagram showing hierarchical relationship between different sets of data. Okay, these are the, so this is in the one group, this is in the one group. This is along with the other group. These are the clades. So simplification clades. These are the leaves we are getting. So this is the dendrogram. We prepare it. And parts of dendrogram, if we study, the dendrogram can be column graph as the image below, or the we have seen the previous page, row graph. Some dendrograms are circular or have the flute shape, but the software will usually produce a row or column graphs. Our this R and this all. No matter what the shape, the basic graph comprises the same parts, and the clades are the branch and are arranged according to how similar dissimilar they are. Clades that are close to the same height are the similar to each other. Clades with different heights are dissimilar. The greater the difference in height, the more dissimilarity. So this is the interpretation we could understand through it. And each clades has one or more leaves. Okay, so you will see here, here that this clade we have 3 leaves. These we have 2 leaves. These we have 1 leaves. Okay, so these are the clades. If I cut this tree by here, so how many groups I will get if I cut from here? 1, 2, and 3. How many? 3.
Yeah.
I just put a line so you could better understand. I cut this tree from here. So how many I am getting here? 1. This is the one group. How many? 1,
2.
2. If I cut from here, how many groups I am getting?
5.
1. No, just here. How many lines are there?
1.
1,
2.
2, and
3. 3.
this is also 3.
Three.
Got it? Now understand. Here you see 1 line and 2 line we have. So 2 groups. Okay. Here we are getting 3 groups. If I cut from here, then I will get 1, 2, 3, 4, 5, 6. I am getting the observation. Okay.
Sir,
Yes.
sir, there one line was written now. Greater is the difference, so greater will be the dissimilarities. Can you please say what does that mean?
Here it is the hypothetical graph basically. When we do with R, we will see the different heights here. We are getting the similar height here.
Yeah.
But in practical, it does not happen. We get in this way the height. Okay.
Okay.
So there is some dissimilarity. So the height are different.
So that height will be basically due to the different data set.
No, different clustering. No?
Okay.
The clusters are different.
How it is close, I think.
Yeah. So
On
I
the
will explain with the R so you could better understand. Here it is the hypothetical. We have taken the one graph from the internet and I just copy paste it. Okay. For the understanding of this, what are the parts of this? Understand? But in practically, the height will be different. Okay. I will say tell you later about it when we work with R. We are just understanding what are the parts and what are these things. Okay. And decisive hierarchical clustering. First, we have studied about the this our agglomerative. Okay. Now, agglomerative starts from the single observation. Got it? Now we start with the single observation. We see the distance of that observation with other observed data points, and then we see the minimum distance. They merge them, and we create one group, one cluster, and then we use any linkage method in the groups, and we find out we merge the groups then cluster, and we make finally we make some segmentations. Got it? And here the divisive hierarchical clustering is it is called a DINA. Divisive analysis clustering. Okay, is a top-down clustering method where we assign all the observations to a single cluster. So these all observations we have using as a one cluster. All these are the observations, and then partition the cluster to 2 least similar clusters. Finally, we proceed recursively on each cluster until there is one cluster for each observation. It is the reverse process of that. So we make one PQ and then RST I have created here, then R and ST. So finally we proceed to recursive on each cluster until there is one cluster in the all. So this clustering approach is exactly opposite of agglomerative. So there is evidence that decisive algorithm procedure more accurate hierarchies than agglomerative algorithm in some circumstances, but in conceptually more complex. It is more complex, divisive. So very few people apply this. The both agglomerative, divisive, hierarchical clustering users need to specify and desired number of clusters as the termination condition when to stop merging. So otherwise you will go to the last point. So that is the thing. So we have in the R, we have the technique, how we calculate it, how do they this sort of divisive clustering. But mostly we do the agglomerative. Okay. So measuring the goodness of clusters. Well, there are many measures to do this. Perhaps the most popular one is the Duns index. The Duns index is the ratio between the minimum intercluster distance or the maximum intracluster distance and diameter. Sorry. The diameter of a cluster is the distance between its two furthermost points. In order to have well separated in the compact cluster, you should aim to higher Duns index. So it is the index just we ratio between the minimum intercluster distance and the maximum intracluster distance. So this ratio we see and then we finalize it. So I will tell you later with the practical. And the distance matrix we use the Euclidean formula, and this cluster we use for the numeric variables only. Okay. And this is the scale of things we use the scale. If you are using the different scale, the age you see there are 2-digit number, and the salary you see there are 6-digit number. So the 6-digit number will dominate on the edge. So we have to scale it, and the J scale or whatever you want, you convert the scale, transform the scale, then you could use it. And there are the types of clustering. If we see the exclusive clustering, an item belongs exclusively to one cluster, not several. Okay, Kmeans does this sort of clustering. Okay, so this is the exclusive clustering. The every item belongs to only one cluster. Overlapping clustering, the some item belongs to many cluster, two or many clusters. So this is the Fuji or Cmeans does this sort of exclusive clustering. You know, this is the overlapping clustering, not the exclusive. And hierarchical clustering, two clusters have a parent-child relationship. You see here, as I have told you. So this is the hierarchical clustering. So we will study only about the K-means and the hierarchical clustering. We want to study about the overlapping clustering because the few data points are common in the many clusters. So
What is this K-mean and
scaling
K-mean?
means we convert that in a Z scale.
Okay.
Z scale, like you have a age. I will explain you that.
Okay.
Just a moment. Here you see, we have a data points, and I think I had somewhere that thing or not. I just see, no. I will show you that. Just a moment. In our practical, I will explain you. And there I have given in the script.
Okay,
That's
sir.
scaling. Okay.
Okay.
I will show. I remember that it is there in the R. So these are about the clustering, hierarchical clustering. Now we talk about the K-means clustering. So K-means clustering is the one of the rock star in the unsupervised learning. K-means clustering. So unsupervised learning and the supervised learning, what does it mean? You know that the supervised learning, we have the dependent variable or the target variable. Okay. And the unsupervised learning, we remove that target variable. We don't include that target variable while clustering. Understand?
Yes.
We don't consider the target variable. Okay. So whatever the independent variable we have, we make the clustering along with that. Also in the hierarchical, got it? It is not, it is the unsupervised. So it is the rock store. K-means is the rock store. It is better than hierarchical clustering. So what is the difference? I will explain you. The clustering including K-mean clustering is an unsupervised learning technique used for data collection. This is how the algorithm works. Centroids are created randomly based on the predefined value of K. First, we define how many clusters we require. Got it?
Yes.
So as per that, we put that, suppose we require 5 clusters. We decided, yeah, we require 5 clusters. And there is a technique for that clustering, how to see how many clusters you have to take. So that I will explain you later on. And we put 5 random points. We choose any 5 random points. Understand? Any 5. It may be very near to each other. Randomly. It may be far away, have some distance between them. And then K-means allocates every data point in the data set to the nearest centroid, minimize Euclidean distance between them. So I explain you this. Just a moment. Suppose I have these data points. Okay. I am choosing here 3 data points. K3 I am taking randomly. You could take any 3. Got it? What I will do, and the procedure is same. Okay. So I will check the distance of this point. I will change the color. And then I will take the distance of this. I will take the distance of each point. I also, for this, I will do, for this, I will do, got it? Any doubt? And we see what are the nearest point. We club them. Got it?
Yes, sir.
So we get one cluster here and one cluster for this. Then we find out the mean of this cluster. Got it? We
All
set a
together?
centroid. This one. Suppose we have got this one first. Okay. Then second I have, it may be any shape. Don't worry. It may be any shape. I have second one is like this. Okay. Sorry, third one is like this because I have done that in this way. So I'm making, got it now?
Yes.
This circle is not useful. It is useless. Okay.
Okay.
We don't have to consider this circle.
Sir,
Now I will find out the mean of this.
sir, is there any cutoff point or threshold through which we can divide this observation in particular clusters?
Yeah, the K we have to decide. We have one technique by which we could use the K. We could set the K. I will tell you on the R.
But how you decide the minimum distance then?
Minimum distance of this point, you see that this point with this point is smaller. So this point will go to this centroid.
Okay.
This point is near to this, so it will go also with this person. We could say this is a leader. There are 3 leaders we are choosing. So this point which is near to it, it will cover it. It will go with that.
Okay.
Furthermore, point will not go with that.
Okay.
Sometimes it may tie. Then we have to decide where we have to put it.
Okay.
It's very exceptional case. Okay.
Mm-hmm.
So this is the way. Then we find out the mean of this and we set the mean. We set the mean here also. We set the mean here also. Okay. Now we see the distance through this mean of each point. Got it? Got it? Of all, we remove this, what you have created, the border. Got it? We remove this border when we decide we have selected this mean. This border is not useful now.
This mean for all point or only for this
All point,
cluster?
all point, all point,
Okay.
all point. Okay. And this is now converted as an ordinary point. Okay. Previous one. Got it? We have the new cent, right? So now we create through this. So we get some other cluster. In this way, then we again do it. Got it?
Yes.
Or when we stop it, when two consecutive terms, the first we have done and the second time we are again doing, the next time we are again doing, so that we are getting the same result. Got it? Suppose I have done the seventh time, this some groups I have got, and the eighth time I got also the same.
Same result mean the mean is almost
same cluster I am getting.
Okay.
The consecutive 2 times.
Mm-hmm.
Then means I have to stop here at the 7th iteration. I have to stop it. Got it?
Okay. Okay.
Is there any doubt to anyone? Yes. So this is a K-means clustering. First we decide the K, then we take the randomly any number, any data point you could select randomly. Got it? I will show you in the PPT also, but I have shown here because it would be better to understand in this way. Na? Here you see the K-means clustering. I have taken these 2 points. So these points are nearer to this. This is the leader here. Okay. And these points are nearer to this. So we have got these 2. Okay. Then I have taken the mean of this. So I have got this mean. I have got the mean of this is this one now. So the few points of these 2 points are nearer to this red star. Got it? So I have changed this cluster and this cluster. Got it? Yes.
Yes.
That doesn't mind me.
Sir, so after 2, 4, 5 time clustering, there should be the mean of both cluster
mean of this
should be same. Then we can stop.
So we say the K means. You know that name.
Okay.
How many means we will get? How many clusters we have? The K clusters we have. So we get the K means. Okay. So the name is K means clustering. Got it?
Okay.
First we take the random, then we take the mean.
Okay.
Okay. First we take the random points.
Okay.
And after that we use the mean. Okay.
Okay.
And this you see, now I have done this. The another time I have taken the mean, so I am this way. And this is, and this time and the next time I'm getting the same. So this is my final clustering. Got it?
Yes.
So this is a way of clustering. Now you see the K-means clustering. SSW is what, and SST, SSB and SSW. You know that SSW and SSB.
No, sir.
Okay. So what does it mean? I explain here in this group. Okay. So SSW, first I talk about the SSW, I change the color so you could better understand. SSW sum of square within. No, so sum of square within, I will take this distance, this distance, this distance, this distance, this distance with the mean. So this is my x1 and x2 and x3 this way. So I will get the x1 minus x bar, x2 minus x bar, x3 minus x bar. Got it? Okay, and then take the square of this,
Okay.
and then get the summation of this. Okay,
Mm-hmm.
that is the sum of square within. Got it?
Okay.
It is the sum of square within. Up sum of square between is what? We see this. Okay, and with other group also, whatever our their mean, and this also. It is the x1 bar minus x2 bar, x2 bar minus x3 bar, and x1 bar minus x3 bar, and we get the square of this. Got it?
Yes.
And we get the sum of square between.
Okay.
Okay,
Okay.
and this both is equal to SST, sum of square of total.
Total.
If we get the distance, these are all okay. Getting it?
Okay.
Getting
Yes,
my
sir.
point?
Yes, sir.
So this is equal to this. When you decrease the sum of square within, the sum of square between will increase. When you decrease this distance,
Yeah.
no, you have the very few, then this between will increase or not? Between two cluster. And the cluster will be
Yes, sir.
far away
Yes,
to
sir.
each other. The
Yes,
cluster
sir.
would be like this.
Mm-hmm.
So sum of square between should be greater and the sum of square within be lower. So that is a good clustering.
Okay.
All the points are very near to each other in a group, and the points are very far away to each other in a different group. Got it?
Okay.
That is a
Okay.
good clustering.
Okay.
So here I explain you that again. That this is a SSW, the number of groups. If the number of groups increases, you see here very carefully, the number of groups increases, sum of square of within decreases. Because you are going to the single observation, no? Towards single observation. Not number of groups increasing, matlab you are going towards single observation or not?
Single within it.
I will tell you that thing. Just a moment. Number of groups, if you have two number of groups, so then in each group you have so many points. Okay, got it? You have, if you are increasing the number of groups, then what will happen? Number of groups are increasing.
Mm-hmm.
So SSW is decreasing or not?
Decreasing.
Here this point and this point distance were higher. Okay, now it is decreasing. Whatever the mean of these, you could assume that. And so this deviation is decreasing now or not?
Decreasing.
So the SSW when decrease, the number of group increases. Okay.
Okay.
And when the number of groups increases, the SSB is increasing. Sum of square between increase as the number of group increase.
Yes.
Sum of square between will increase. Okay, it is the just opposite of that. If you increase the number of group, so sum of square between will increase this. Okay.
Okay.
This will increase. So because why? You are making the mean only, na? The sum of square between this mean and this mean and this mean.
Yes.
So there are so many mean distance you will take, and you get the square of that. So it will increase.
Yes.
Okay, so the sum of square between will increase. Got it? And
Okay.
this thing is called the SST. Both summation. It is for the, I will show you for the this part that SSE and SST I will explain you here. Here I have written the SSE basically. It is not a SSE, it is a SSW basically here. It is I have taken from the regression problem. I have just taken that slide for better understanding. Here you see the mean is the 3.5. And I have divided in two parts. The mean is less than 3.5 data would be here, and the more than equal to 3.5 would be here. So if I find out the mean of this would be 1 and the mean of this would be 6.5. Okay. So my this SSW, I just want to show you that my this SSW, what I have taken the SSW here and the SSW here, sum of square between within. So this is this much. And SSW1 and SSW2, we could say that. Instead of E, you could assume it is W. And it is always less than, the sum of SSW is always less than total sum of square. It is less than 3.5. Total sum of square, if we see, if we measure not the 3.5, if we measure the difference 3.5, 1 minus 3.5 whole square, 3 minus 3.5 whole square, 2 minus 3.5 whole square, we get that thing. And then we get the summation of that. That is always greater than the summation of 1 minus 1 whole 1 minus 1 whole square, 3 minus 1 whole square, 2 minus 1 whole square, minus 2 minus 1 whole square. We get the summation of these. We get the summation of 10 minus 6.5 whole square, 4 minus 6.5 whole square. We get the summation of this. That these two summation would always be smaller than the summation of this one, previous one. Got it? So you see what is happening here. It is also SSB. Basically, what we are calculating here, SSB, TSSE, I have E instead of E, what I am telling you, you have to write the B. So this SSB is the major one, this SSB 1 and this SSB 2. So this, the sum of this SSB always less than this. Here you are increasing the clustering, increasing the group. You have two group. Here we have one group. So the one group sum of square between would be higher than this one. And if you divide again, so this would be higher than these two. Okay. So I will tell you later on why we are explaining it. K-means clustering now I am talking about. That I have explained you about what is the K-means we are working here. So it is the X have the value and the mean is 3.75. You know, I'm explaining the mathematically now. And the X minus mean of X. So minus 2 minus 3.75. So I'm getting this value and I'm making the square of this. So I'm getting this one. So the total SSW, I have 95.5. Now I have divided this into part. One I have taken this and one I have taken this. 4, 5, 7, 10 I have taken here. The one cluster and the second cluster is here. Again, I find out the mean of this. So I get the mean is 1. Here I get the mean is 6.5. And I do it. The same data I have taken from there on that graph. And I find out this is the 14, this is the 21. If you add on this, I will show you here. 95.5 is always greater than 14 plus 21. Got it? Okay. So when you increase the group, the sum of a square within decreases, as I have shown in the graph, first graph. Okay, does that make sense to everyone? Now, elbow method we use to find out the optimal number of clustering. Sum of squared of errors we take, just as I explained you earlier, sum of squared of errors means the sum of square of between. That is the within, sorry, within, not between. That is the same thing. SSE. So as the SSE decreases, the number of group increases. If the group are more, the sum of square is low. Or we see this decrease, and where we see the low fall, here you see it is the high fall. If we go from here to here, 1 to 2 cluster, if we go, then it is a high fall, the sum of square of errors. And then second to third we go, there is a little bit less fall is here. And if we go here, it is very steady. It is not a steady fall. It is a very normal fall. So we could consider the 3 clustering. After this, the sum of square error is not decreasing. Sum of square within is not decreasing as much as it be. Got it? Any doubt?
No, sir.
So we, as per this, we decide how many cluster we have to take. Okay, K we decide through this. Aditya, got it? Yes.
Yes, sir.
So
Yes,
this
sir.
we will do there in the arc, and we see sometimes we may confuse. We have to choose this one or this one. So you could apply both. First this one and later on this, and you see. Okay. Sometimes, but we could easily recognize that what is the y over x, delta y over delta x. We have to see. Okay. If delta y over delta x is low, then we don't have to proceed further. Then it is higher, then it is okay. So I will show you here what is delta x and delta y if somebody don't know. This is my delta y and this is my delta x. So delta y over delta x ratio is greater than 1, then it is okay. We have to consider for the next. Here also we see make it this way. And here we see, okay, it's okay. We have near about 1, may not be, maybe near about 1, maybe less than 1 also, but not much less than. So it is okay. We are going to third one. Okay. And if you see here, it is very low. Delta y over delta x. Getting it? So we will not shift here. Got it? Any doubt?
No, sir.
So I'll just clear it. And this now finished the theory. Now we start our R. Just a moment, I decide which script I should start with. I will start with this, the segmentation clustering script. So I'm using the dplyr, ggplot2 and the cluster library. And this library you have to install the cluster library. Dplyr and the ggplot you are already aware. So I'm creating one data set for the age and for the income. And I'm hypothetically setting some factor. And I have taken the 6 data points, and the 6 data points I am converting in the 3 groups. Group 2, group 3, group 1. So as a factor G1 I am taking as a group. I will consider with the name. I'm making a data frame with the age and income only. And you will see it. And I just removed the lots of things in my hair. So I just again run it. So this data frame I have a 6 observation, 2 variables. So you see this is the age and income I have. Now what I am doing, I will just show you the one graph. I'm creating one graph for this. D is the data frame, and the aesthetic I am taking on the x-axis age, and the y-axis I am taking the income, and I am filling the color within the aesthetic with the G1. G1 is the 1, 2, 3. The 3 colors I will prefer there is per the group, and I will make a geom point. So you will see this I have. I will show you. So this you see, these are the points, and these are the points, and these are the points. How many cluster would be there? What do you say? We have the income in this way, 148, 150, 152, and these in the thousands.
I think today.
3 clusters we are getting. Okay. So what I do, these are, you know that this may be include here. This blue. What do you say? The distance of this is low.
It's a car.
Okay. This blue should go with this or go with this. What do you say?
From upside, I think. Blue and blue.
I just write few names so better understand. This is a point. We have the, you measure the distance here and measure the distance. Which one is greater?
Oh, maybe upside is greater.
This one is greater. So where it should go? It should belong to this.
Yes.
No?
Yes.
So, but it is in a blue color. So it is here we are it is belonging to this. Got it?
Yeah.
But actually it should belong to this, no?
Yes.
So that is the difference, because both scales are different, age and income. Okay. So that is the importance of the scale. We change the scale. How we change the scale? The first conventional approach, if we use, here you see it is the 2-digit number, this is the 3-digit number. So we could convert this 3-digit number in the 2-digit by divided by 10. One basic approach.
Yes.
And if we divide it by 10, we will get the 2-digit number basically. Now I am getting the 2-digit. Here also 2-digit. Here also 2-digit. Got it?
Yes.
Again I make this graph. Again I make it. Now it is like that. It's very odd graph. It is not giving us the clear picture.
Okay.
So there is a standardized technique. There is a normalized standard scaling that is called. So what we do in the normalized standard scaling, that is the G scale we are applying, the age minus mean age. As I explained you earlier also, the G scale formula, Z is equal to X minus X bar over standard deviation. Got it? So this is the age x mean of age x bar, got it? And the divided by standard deviation of age, got it?
Yes.
So we are getting it. Similarly, we are doing this for the income. Same thing. Income minus mean of income divided by standard deviation of income. Got it? So now I run it both and I will show you the D. You see the values are in the same manner now. If I show you the mean of both now, new mean of age, so it would be near to 0. What is the mean here? What is the mean? In the console, you see the mean of income, I tell you. That is also 0, 1.77 into 10 to the power minus 15.
Yes.
Okay. If you round it off, 0. Okay. So we have the same scale now, whose mean is 0, and SD would be 1 for the both data. If I ask about the SD, one. Okay. If I see the SD of that is also 1. Got it? Their now their variance is same. Their mean is same. Okay. Points are different. Data points are different. Got it? So now I visualize this plot of this data. Look at this. Now what do you say? Where it should go? Now it should go here. Got it? So it is the, you see the scale 0, 0.51, minus 0.5, minus 1. In this way you are getting the scale. Any doubt now? So whenever you perform the clustering, please scale, normalize, standardize the scale. Now I will give some idea about how to create a scree graph. It is the K 100 minus 100 into 0 0.1, 0 0.30, 0 0.45. I have selected these and the data frame I am making this and the plot I am going to make this plot, and I will show you this plot. So this is the plot I have got here. GM point color SSW SSC. I have just make one hypothetical scree graph. 1 to 10 factor. I have taken the K as dot factor. So how many would be there? How many cluster would be here? Can you say me? Yes.
4, sir. 4.
Correct. So this is the scree graph I have just created here hypothetically, so you could see how does it look. And we see later on. So now I am taking empty cast data, and now I have taken this. Okay. Empty cast data, everybody aware about? So I just make 2 by 2. I'm showing you this we have. Then I will show you the plots for these other variables and these 3 variables. And then I convert this in 1, and then I remove the VS and AM, which are the 2 only, and rescaling the data. Apply the other scale, not that you know that we have a scale, G scale, we get the mean. There is the mean through the mean. So here we are taking the median. We are taking the deviation through median. Previously we were taking the Z is equal to X minus X bar over sigma. Here what we are using, because the every data, most of the data, if I show you that it is a positive skewed, positive skewed, positive skewed, getting it? Most of the data you see, it is a little bit positive
So
skewed.
the data has to be normally distributed, sir, for doing K-means clustering.
No. What, as per the data distribution, we have to decide
Decide.
what standard scale we have to choose.
Okay.
We have a two-way. First, I have explained you Z is equal to X minus X bar over standard. It is for the normal data. Okay, if I have the data is normally distributed, correct? If you have a data with some skewed, okay, then we have to use a different scale. That is also a G median scale, we said. So it is a X minus median instead of mean. And we divide by the mean absolute deviation instead of standard deviation. Got it? And then this mean absolute deviation is taken from the median. Okay. So this formula I am applying here, medians, I have given the object name median. Apply function I am using, the MD is the data for the each column, 2 is the margin which shows the each column, and what we are calculating the median. And the maths I have taken another, there is the mean absolute deviation for the each column. Got it? I am just hypothetically taking the some are normal, but I am taking considering them as a skewed. I just run it, and I'm scaling the whole data now. Car standard scale MD, new data set I am giving name car standard data, and MD is centers, medians, and scales mates. The center is the whatever the central tendency you are taking, and the scale is whatever the deviation you are taking. So this I run, and I will show you this car standard. Sorry. You see, this is the car standard. This is the mileage. This is the cylinder. This is the value. And the another scale. We have the 32 cars. Okay. Oh, this is also giving us the that values in the scale what we are considering. So car distance, we see the distance. First, we have to make a distance. So I will show you this is the distance between different cars, different observations. Cars are the observations, the models are the observations. So you see, I will just show you the distance between the whole distance. If we see the multi-dimension, the MX Mazda RX-4 wagon with the Mazda RX-4 only, it is the distance. This X4 we don't will the WEG we won't get the distance of this the similar same car model. And here we are Datsun 710 with this distance. So it is the distance we are getting. Got it? Accumulative distance for all. And now I am applying the hierarchical clustering. So car H cluster is a function we have, and the car distance. First we have to find out the distance with the dist function. First we have to normalize the data. So we have not the normalize, the standardized scale. We have to take the data, standard the data, we could say that. And after standard the data, you find out the distance, and that distance you put in a H cluster. And I will just show you that plot. So this is my plot. Oh, why I'm not getting that? Just a moment. I have to convert them. Oh, now it should be better. Got it? You see, this is the edge clustering. Now we have to cut off it. How many cluster you require? So if I just show you, as I explained earlier also, if I cut off from here, we are getting the 2 cluster. If I cut off from here, how many clusters we are getting?
4.
1, 2, 3, 4 clusters. Correct. If I cutting from here, 1, 2, 3, 4, and 5 clusters. Got it? Understand?
So how to decide this cutoff?
That's the script plot we have to develop. No, I will tell you later about that graph.
Okay.
Okay. So this is the complete. Now we have to select the cutoff only. Okay. Clear. Now how to select that? I will explain you. WS is within sum of square. Yeah, sum of square within. And row call standard -1. The sum apply this and I run this. I will show you how to create this. I will don't go in deep. You see, this is our how many cluster would be there? We have 32 observations. And this is the within sum of squares in the group. This
4
much?
or 5.
5, I think 6. Okay. Then it is increasing. But this is wrong. It should not increase anywhere. It will always be downward. I explained you at that moment in the PPT. It is always less than previous. Got it? Yeah. I explained you that.
So there is some error in calculation.
Yes. I will find it out. Here I have explained you now. This is always the sum of this is always less than the previous one. So here if it is increasing, then there is some mistake. It should be like this. Okay, it should not up anywhere. Okay, we see what's the problem. Well, there is some bug, I think. Sometimes it works and sometimes it does not work. Some Kmeans center side.
Sir, hierarchical cluster and K-means cluster is a different method, right?
Yes, yes.
But in the code we have used K-means.
That's I am searching that. Mhm. Just a moment, I just see one thing. I just see one more thing. Still, I am getting that thing. It is increasing. It may be due to we have taken some discrete variables. Okay, it may be due to that also. I think so. But 1, 2, and 3, and 4, then 5 and 6, and then it decreased. Huh? Up to 6 factor we could take here. If we see 6 factors we could choose here. So why it is coming that way? Everything it is giving me the different graph. Look at this. What is the problem here? Because we are using the Kmeans. Okay. We are using the K-means. So K-means always give us the different because it take the random points and then it will decide. Okay. So it is giving us the always the different plots, but we don't have any other technique by which we could decide it. So what we have to do, one approach we could use here. I explain that approach. I again said this skill and I will show you that approach what we could use there. So I just apply the hierarchical clustering here and I will show you this plot. I am not going with this, okay, with the script plot. I just cut it by the 3 cluster I want, suppose. So cut 3. So I will show you the in the 3 cluster you will see this match the RX4 will go to first cluster. This go to first, this go to second, this third, this two. This way I will get the membership. And I will show you the table of this. So it is the in the first cluster there are 7, in the second cluster there is 15, and the third cluster there is 10. If I show you here also 7, 15, and 10, you remember this. And I will show you if I take the 3 cluster, see how many we get over there. So I will approach some other technique, and we don't have time to explain it. Tomorrow I will explain it. I'm taking the line from here. Okay, this is like that. So I'm getting the 3, 1, 2, 3, and how many? 7. So in the 7 we are getting the which are very low height. That is the first cluster. Got it? So I will just a moment. I just take just a moment. 7, 15, and 10. This is the 7. So 1, 2, 3, 4, 5, 6, 7. And then 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 15. 1, 2, 3. So it is depends on the height. This height is lowest, so it would be the first cluster, this is the second cluster, and this is the third cluster. Got it? Based on the height. Okay? Got it?
Sir, if it's based on the height, I think first will be 7, second will be the largest one, 15 you said, right? 3, 4, 5, 6, 7, 8.
It is not giving.
And third one will be 10, right? Based on height.
Based on height, first would be this 15.
Okay.
And
Then it will be 7.
second would be this, and the third would be this. It is the you see here. Okay. It is like that. But why it is not coming that way? I just see. Line is straight, correct? Why we are not getting that way? But first is 7, second is 15, and third is 10. So there may be some. If we again draw it, then we could get better. I think so. Okay. Sometimes it's a zoom, and this way we get some margins problem over there. Height, we calculate this distance. What the height? Okay, the horizontal bar and this. So this is our first. This is our second. First. Then second.
Sir, I think it's grouping based on the number of rows, number of observations, 7, first, second, and third.
No. You see the
7,
15.
okay. 7,
It is
15
not based
and
on.
10.
Yeah, it is based on the height. I know that. But sometimes the graph, due to the visualization, it don't give us the clear picture of that sometimes. Okay, let we see tomorrow this. I will again draw it and we see, because it is always based on the height. No? I will see tomorrow what's the problem with this graph. Okay, you could take one also now.
Okay, sir.
We could take one more thing. I just try that. Now you see. Right. It is still same. Okay, I will see it. What's the problem with this?
Sir, sir, one line was there now, 100 minus 100 into C. Can you please tell that? Like I missed out there.
That for the scree graph, I have created one table for showing you the scree graph only.
Okay.
Okay, so how does it look like? That is not it is the hypothetically I have to create a graph. How does it look like? I just want that thing.
Okay, that is skewed one.
Yeah.
Okay. Yeah, this K equals to
This
1.
how to create that graph. I have not taken any data here.
Okay. So that is 100 tilde 100, is it? Or minus?
That is minus
Okay.
100 minus 100. Okay, tomorrow we see it. Don't worry. Okay. We cover it tomorrow. I will see what's the problem with this graph. Okay. Generally, we see the height, and as per the height, we decide the first group, second group, third group. Okay. So let's we finish this, and we meet tomorrow. Okay.
Sir,
Yes.
I have a question. Is there any way to transfer plots from R into Word where it is like in editable form? Like we
No,
can
no.
change the font size or something?
No, we could change the font size here in R itself.
No package to like transfer like that?
No, we could transfer it. We could transfer it.
No, like in editable form.
No, I think there is nothing. I have not seen up to save
I
image.
was reading some articles and they said that there is some package called Officer or something, and with that they can transfer in Python also and in R also.
That is not that is a not a package of R. I think that
Officer?
that is a separate package. I think that.
They said that if we use that, we can transfer into this PowerPoint in editable form.
Okay, I will see it. If
Okay.
something is possible. We could edit here everything you want. You could do here, and then you could export it.
The issue is like my work, it is in with like different institutes are doing. So they send me some file and like some figures, and I want to change something in that, so I'm unable to do that. So that is why. Otherwise, I'll have to like redo all the data that they are doing.
Okay. So you are getting the
Figures.
figures in which format?
Yes. It is in the Word file I get, or images.
Images.
Yes.
There should be some different. It is not related to R basically thing. This is some other tool you could use for that.
Like
that is what you are telling. That is what tool name is. Office.
Yes.
It is not a R package. I think that.
Okay.
I think so.
Can I say something?
Yes.
For the formatting of the font and axis in any image, you can use Adobe Photoshop. This is freely available, so you can download and you can modify your picture according to your requirement.
Even the photographs?
Yes, everything you can modify it by using Adobe Photoshop.
Okay, okay. Thank
Adobe
you.
Photoshop. Yes.
Yes.
Thank you.
Mhm.
So thanks everyone. Let me
Thanks, sir.
wind up this. Okay.